Hello and welcome to Disseminate the Computer Science Research Podcast. As usual, Jack here. Today is going to be another installment of our High Impact series, but before we get onto that, I need to give a shout out to our sponsor, Pomtree. Pomtree are the developers behind Raftery, the open source temporal graph analytics engine for Python and Rust. Raftery supports time traveling, multi-layer modeling, and comes out of the box with advanced analytics like community evolution, dynamic scoring, and temporal motifs mining. It's blazingly fast, scales to hundreds of millions of edges on your laptop, and connects directly to all your data science tooling, including Pandas, PyG, and LangChain. So go check out what the Pomtree guys are doing at www.raftery.com, where you can dive into their tutorial for their new 0.80 release. Today, we are going to be talking to Joe Hellerstein. And now, Joe is the Jim Gray Professor of Computer Science at UC Berkeley, where his research focuses primarily in the area of data-centric systems, and he's interested in the way they drive computing. Joe has won numerous awards across his career. He's won the COD Award, the Alfred P. Sloan Research Fellowship Award, and also he's been featured in Fortune's magazine's Smartest in Tech list. He's also led numerous open source projects, including Bloom, Madlib, and Telegraph. And he's also started several companies, including Aqueduct and Trifecta. And for new listeners to this show, they'll know this type of episode is based off of a blog post by Ryan Marcus around the most influential people and papers in databases. And Joe, you're number 8 in the rankings at the moment, so doing good. Welcome to the show.
Thanks for having me. It's fun.
Awesome stuff. Cool. So I've given obviously the highlight reel there of everything you've achieved so far in your career, or some of the things. But yeah, help us color in between the lines now and tell us about your own journey in your own words.
Let's see. So I was born into the database research community out of IBM, Berkeley, and Wisconsin back in the day when those were sort of the 3 dominant areas of database research. So right after college, I did an undergrad at Harvard with a woman named Mei-Shin Xu, who later on went to HP Labs. And from there, I went to IBM Research as a pre-doc intern in the lab that, was famous for System R and R star. And they had a project at that time called Starburst. So as part of the Starburst team, working on query optimization. And that stuff apparently still ships in DB2. So that was long ago good stuff, extensible query rewriting. And then I went to start a PhD at Berkeley with Mike Stonebreaker on the Postgres project. But being a young man and full of beans, I decided after 1 year that wasn't where I was happy, and I transferred to Wisconsin, which is actually my hometown, and finished my PhD there with Jeff Naughton. But I continued to work on Postgres. So my PhD work is all in the context of the Postgres project. Mike Stonebreaker was super supportive, helped recruit me back to Berkeley as a professor, and I've been there ever since 1995, leading my own research. And expanding out of core database systems into all kinds of things that interest me where there's collaboration. Stonebreaker left Berkeley a few years after I arrived, which sort of forced me into collaborating with other folks. And so I've been working on things like machine learning and data visualization and networking and operating systems and how those things connect to data management over the course of my career.
Awesome. So did you always kind of, going back to the kind of, 12-year-old, 13-year-old Joe, did you always want to become a researcher? Was that always the sort of desire from being very young?
Yeah, well, it's kind of the family business. So my dad's a mathematician. He was a professor. My mom was what was called a systems analyst, which means COBOL programmer. So I kind of fell in between them, but I also have 2 big sisters who went on to grad school and became professors. So I just did what everybody else did. I was well behaved as a child. And so I just went into the family business.
Awesome stuff. And also as well, it's the first time I'd heard about Starburst there. Now the name of that, did you have Starbursts in the US, the suite, right? Like the little suites?
I believe they were there at that time.
Right. Okay.
Long enough. But yeah.
Cool. Awesome. So let's get on to what you're working on currently today then. So yeah, give us the high level overview of the stuff you're working on today.
Yeah, well, the primary project I'm working on is a project called Hydra, and it's the culmination of a very long effort on my part to bring declarative languages and their power to other areas of computer science. And we did this in the early 2000s in declarative networking. So we showed how you could write networking protocols in high-level languages, and then compile them down from those high-level languages to implementations that made sense in different contexts. Like the same spec would give you a wireless protocol or an internet protocol, depending on how you costed out links and reliability and stuff. So there's a whole generation of work on declarative networking. What we're working on right now is high-level languages for distributed programming in general. And the thesis here really is that there's only one language that succeeds in scaling from one core to the globe, and that language is SQL. It runs in your phone on, in SQLite, and you can take the same query that runs in your phone and run it on Snowflake across the globe. It's pretty amazing. Most programmers don't think of that as an option for writing general purpose code. So we're trying to figure out where those gaps are and what are the optimizations required for general purpose programming to scale up and scale out across lots of machines. And we've, in the Hydra project, we've got a prototype going now after a couple of years that can do some pretty cool things, ranging from we can optimize low-level protocols like Paxos for high bandwidth as implemented in Hydro. And we can also build systems infrastructure like key value stores that auto-scale in Hydro as well. And you get very tight specifications that automatically optimize themselves.
Awesome. Is this already integrated into sort of GCP AWS, or is it sort of, how is that path looking like for it to be sort of general purpose, I guess?
Yeah, well, we're on a road with that, and we actually have some developer support from Sutter Hill Ventures. So they have a couple developers who I actually manage, who contribute to the project. So we have some professional coding as well as grad student coding going into this.
Yeah.
And it's a Rust library, and so it's all in the Rust ecosystem. And we're not in general release right now. Certainly, you can go to the Hydro project GitHub and play with it, but we're still very much in research mode right now, but I'd say in the coming 12, 18 months, we should have something that's worth playing with.
Awesome stuff. Cool. Yeah, I kind of while we're talking about the Hydra project, and I mentioned Starburst earlier on, but I see one of the key components is also called Cloudburst. Is that in any way a link back to Starburst, or is that just kind of Cloudburst sounds cool, right?
Yeah, Cloudburst sounded cool. That project is end of life. That was a very early Hydro effort. The folks who did the Cloudburst work, which by the way, was functions as a service with state. So think of Lambda with good state management. So we were all very disappointed that Lambda didn't have any data when it first came out, and we wrote a sort of an opinion piece about that created a stir. But when we did something about it, we built Cloudburst. So the folks who built that actually have gone on and started a company. It was called Aqueduct, which you mentioned, but names changed to Run LLM in a sign of the times. But it's essentially a cloud-hosted environment, the infrastructure, and the target application there is doing retrieval augmented generation. So document results in an LLM for API driven software. So if you want an assistant for your open source package or your company's APIs, Run LLM will build you one and host it.
Sweet. We'll put a link to all these cool things in the show notes, so the interested listener can go and check them out. Cool. So yeah, this podcast likes to talk about high impact, right? It's called the High Impact series. So let's have a little bit of a retrospective now on your career, Joe. So the first question I want to ask you is, what are you most proud of in your career so far? And does this necessarily correlate with your work that's been the most impactful?
That's a great question. I think I'm always most excited about what I'm currently working on, but it comes from somewhere. So looking back, I'd say, one of the themes in my work was responsive software, interactive software around data. So going back as early as the grad school days, mid-90s, I was interested in this idea of online aggregation, where you ask a query where, it's going to take hours to compute and maybe only produce one answer or a small table of answers. Can we get early returns from that election, so to speak? Can we get a prediction of what the final result's going to be while it's running? That early work got me interested in how databases interact with humans, because it was really driven from human impatience. And this, by the way, was the very early days of web browsers. So I also was very enthusiastic about the Netscape Navigator. When it first came out, its chief feature that I liked over Mosaic, which preceded it, was that it had interlaced GIF support. So your images would start to download over the small modem the small baud rate modems incrementally, so you could get an early view of what the pictures were going to be before they fully downloaded. And I just thought that was super great. I wanted to do that for queries. So this was very much human-driven work, and that made me realize that like for compute intense or data intense tasks, there should be some care for like what's the user experience of that. And that drove me generally to be interested in interactivity and streaming and all these kinds of things. And that knits through my work in a lot of ways, particularly as it meets declarative specifications. So I was super disappointed when MapReduce came out, because MapReduce was the exact opposite. It was like, we're going to do a big batch job, and between every stage, we're just going to put everything on disk, and there'll be no outputs for you, sir, till we are all done. And I just thought that was such a big step backwards, and everybody was so excited about it. And I sort of said, but you could stream most of the things that MapReduce does. For instance, it did joins as reduces, which meant that you don't get any join output till the full join was computed, which is just not required. This then fed into a whole bunch of work in my group on like, when do you really need barriers? When do you really need to block, and when don't you? Which led to the column theorem, which is this question of like, what is coordination for? And so a lot of sort of the deeper results, the column theorem, which I'm proud of, the ideas of online aggregation, ideas of streaming declarative languages for networking and for distributed systems. A lot of this comes out from the beginning of this idea that like computers should give you answers right away. And there's, just being impatient and wanting to be interactive and not do batch work. Yeah. Batch work's from like mainframes. I don't understand why people...
But yeah, it reminds me of a keynote you gave at the VLDB Sydney with Jeffrey Hare. I remember it being kind of blown away. There's the first time I seen it was Wrangler, right, was the tool, I believe, that was demonstrated. Been blown away by it and been like, oh yeah, that's kind of why are all tools not like that? Like, but yeah, it was really, really interesting. Remember it at the time. It springs up to mind. Cool. No, that's a really awesome answer to that question. So kind of again building on this sort of retrospective sort of topic, what's the most challenging project you've been part of?
Well, probably, you brought up Wrangler and Jeff Hare. Jeff and I took the Wrangler code with the student who wrote it, Sean Kendall, and the three of us started a company, Trifecta, to commercialize that work. So this is interactive, essentially AI-driven synthesis of code for data cleaning with visualization built around it. Those words weren't the words that were used 10 years ago. But doing that startup over the course of a decade was the hardest work that we did, the hardest consistent ongoing work. Doing a company that like lives on, a 10-year journey for a company is nights and weekends and a lot of heart, and just many, many people engaged who you're mentoring and caring for and collaborating with and learning from. And that was a full body experience, kind of in the same way that my other job of being a professor has been a full body experience. But the professor thing is like a career and a title, and the company is like a chapter. So when you asked me about projects, that was the biggest pull.
Yeah, cool. Would you tell yourself, would you do anything differently if you went back and had to do this sort of journey again? Would you be like, maybe do this different, that different?
Yeah, I don't indulge in that kind of thinking much. I'm kind of a forward-looking person.
That's the way to be, right?
Yeah. In part, this also goes along with my very countercultural for San Francisco point of view, which is that like personal optimization is not something I like to think about very much.
Cool.
Most people out here, they're like, I'm going to, do everything to the nth degree and make sure that I'm always being efficient in my athletics, in my eating, in my, how I get to work. I'm like, you know what? Get up in the morning, live life, and be joyous. So part of that is also not looking back and saying, what if, or what should I have done better?
That's fair.
But I suppose you'd like something that I can share with students and with people coming up. From that respect, I do think, I never worked a Saturday in my life because of religious reasons. And I think that's been very healthy for me. So religion aside, having some discipline for downtime is, I think, something that I'm very grateful I always did. So that's a thing I would do over again. Religious or not, because that changes in a lifetime, maybe over a lifetime, many times. But I think dedicating time to downtime in a disciplined way where you don't let yourself off the hook and then work, that's really good, even regardless of how busy and committed you are. In terms of projects, I would say I had wonderful mentors. They were mostly pretty hands off. I wish I had learned to be a better teammate. I think one of the cool things about doing a company was that it was a collaboration that was forced by circumstance. We have to work together to grow.
Mm.
As a professor, it's really easy to work on your own. And while I've collaborated a ton, um, I've only really had one shared project, I would say, that was an ongoing campus project. That was the Telegraph project with Mike Franklin, which was a great deal of fun. But there's something I wish I was better at, teaming up on running things. It's a skill that I feel like I still need to work on.
Nice. It's funny what you said there about going back a second about sort of everything being data driven and over optimizing. I'm a sucker for that as well. Like I have this Aura ring now which tracks my sleep and everything, and you just get so like, oh, I didn't get enough sleep last night. I only got 7 hours 13 minutes. Like, oh, I need to get my 8 hours, and yeah, it is wild. But yeah, trying to detach from that is and just give yourself a break a little bit and unplug from reality maybe, or from the modern world, is definitely needed. And not feeling guilty about taking time off as well, because I was a sucker for that during my PhD. Like, oh, I should be working, but yeah, sage advice for sure. Cool. Yeah, let's talk about motivation some more. So what are your favorite papers? I saw you do a tweet recently, actually, but maybe along these lines. So that might be like about one of the papers. But yeah, go for it, Joe.
I think, I have papers that I enjoy teaching because I teach a graduate class. And you go over them enough times and you don't, they're good vehicles for teaching. Whether they still inspire me is hard to say because I've just pored over them over the years. But I think there's early papers and databases that just ring. They just keep working. They keep making sense. So the System R sort of retrospective paper is just great. The Pat Sellinger paper on query optimization from '79, everybody calls the Bible of query optimization. It's spot on, and just it was so well seen, that this is the problem to be solved and this is how to think about it. And if you almost can't appreciate it unless you read other papers like the Ingress query decomp paper from around the same time, and they just look incoherent now because at that time nobody knew what the problem statement was. They were kind of noodling about. Sellinger got the problem statement right, and after that everything flows, like decades of research flow. And so there's papers like that just make sense now because they fit our mental model of the computation problem. But at the time, she was just pulling that out of thin air, like putting structure on an unstructured design space. So that paper is great. A less known paper that I love teaching is a paper by Mike Carey, Rakesh Agrawal, and Marone Livni on performance studies for concurrency control protocols. I don't remember the title off the top of my head. It's from the 80s. And at the time, there was controversies over whether locking was better than optimistic concurrency control. And there were papers that had come to completely opposing conclusions. So the thing that's great about this paper is that it says, how could it be that science tells us two opposite things? Well, it must be that the scientists were making different assumptions. So let's crack open the space of like, what assumptions could you make with a well-formulated simulation mechanism, and then see if we can set the knobs on this simulation to explain how they came to these different conclusions and perhaps inform what a real-world conclusion should be for this controversy. And it's just this beautiful study in like, here are performance graphs that tell a story, and they explain what's going on. I love that paper, especially for students, because so many research papers we write, they have performance study at the end that says, I win, you lose. I win, you lose. I win, you lose under many parameters, right? I win, I win, I win. And those tell almost no story at all, except that binary story. This paper shows you what performance studies should be. And it also like brings to the fore the point that the graphs aren't the issue. The issue is understanding the problem. The graphs are there to explain your understanding of the problem. And I think so few research papers in computer science do that well. So I love that paper. This year, I added a paper to that reading, which is by a postdoc of mine, Timo Bang. It's called The Tale of a Thousand Cores. And it was his PhD work, actually, where he was trying to explain, again, results from Mike Stonebreaker's group at MIT that had been done earlier on concurrency control, but in this case, and multiprocessors, like 1,000 core processors. So they did this paper, Staring into the Abyss, with 1,000 cores. So Timo implemented all their stuff. He took their simulator and put it on a real machine and got completely different answers than they did. So their predictions, their simulations appear to be all wrong. And again, he goes through this sort of iterations of assumptions and setting up the problem so that you understand it's not a simple story. It's not an I win, you lose story. Yeah. It's all, performance studies are all about what is your context, what are your assumptions, and why do those assumptions and context lead to the conclusions. So I love that. I'm a big, I get very grumpy. Let's just say that I get grumpy about people who are like, you don't have enough graphs. You know, this won't get into SOSP because you haven't studied it carefully enough, by which they mean you haven't put in the sweat equity to meet our community's standard for sweat equity. But I look at the papers that come out in a lot of those conferences and there's just garbage graphs. They have no bearing on what might connect to the real world. They tell you very little about what parameters of the setup or the deployment would affect the results. And they've been done at great cost to student time. And in these days, cloud costs sometimes if they have GPUs involved. Yeah. And the conclusions, you can show me lots of graphs. That doesn't mean that you have a fine-grained understanding of the problem. It just means you ran a lot of experiments and plotted them. So I really like that Kerry Agarwal-Livni as like it's my avatar for, should I even have a performance study, or have I already explained the solution? The graph is just there for window dressing, right? So anyway, those are a couple examples. Of course, you know, in like the data visualization side of my brain, the work on Polaris that led to Tableau, the grammar of graphics realized as software. I think that Jack McKinley's thesis, that's beautiful work that I learned about, you know, in my travels into visualization land. I'm trying to think of other stuff that kind of knocked my socks off. I think the Chord paper by my colleague Jan Stojka, David Karger, Franz Kashik, and others is a lovely paper from peer-to-peer days that I thought, you know, was quite influential on my thinking. I just thought it was super cool and went and ran off and worked on related things because I thought it was cool. Those are some.
That's awesome. Definitely a few more on the reading list there. So yeah, good stuff. Yeah, so I guess kind of, I'm not sure if we've covered this off really, but kind of inspiration and which ones of these papers or people have had the biggest sort of impact on your career?
Well, people, I mean, personal mentors. I've been super fortunate. So people at IBM, well, even, yeah, Mei-Shin Shu, who people don't really know about so much. She was a wonderful, she got me into the field as a college student. She was a Harvard professor at the time. But then at IBM, just the whole crew of people, starting with my boss, Hamid Pirahesh, very influential, Guy Lohman, Laura Haas, Pat Sellinger, Jim Gray. He wasn't there at the time, but I met him through them. And then Mike Stonebreaker was super influential on my career. He was my master's advisor, and then really one of my PhD advisors and colleagues over time, and oversized personality for our field, certainly over the years. And, you know, he's a source of friction sometimes. And, you know, sometimes to create a spark, you need some friction.
Yeah, exactly. So, yeah. If you want to make an omelet, you got to crack a few eggs, right?
That's right. So I don't always have fun with Mike, but he has definitely forced me to think hard and sharpen my arguments, and sometimes use him as a counterpoint to, you know, I'm not going to do it Mike's way, so what way am I going to do it? So he's been great. Jeff Naughton, my thesis advisor, much gentler mentor, saw me through some rough times. Everybody has rough times in their early career. I had my share. So those are some people. And then intellectually, since then, Christos Papadimitriou was an amazing sort of source of just like the joie de vivre of doing computer science and enjoying it. That guy, there's nobody like him for just joyful embrace of ideas. That guy's so exciting to hang out with and see lecture because he just loves computer science. He conveys that love through the way he lectures and talks about work and collaborates. Jeff Hare, my collaborator at Trifacta, as a visualization thinker and builder, you know, wonderful open source builder. He led D3 and Vega, and he's been very successful in open source, but also such a deep thinker and so articulate. He's been a real influence. So those are some of the folks that I've worked with who've been really inspiring.
That's awesome. Whilst I've got you on, Joe, I want to ask you this question. So I believe you're the author of this video, and this had a big impact. And actually showing someone at work the other day. This is the crazy concurrency control video on YouTube. Is that you that made that?
Yeah, that's me.
That is absolutely outstanding. It's brilliant. Even now, we were having dinner the other week. We had an offsite at Neo, and I said, Dave, you must have seen this, and a few people hadn't seen it, and everyone was absolutely loving it. Like, yeah, tell us about that a little bit more, because I want to use that as the intro music to the show, if that's possible as well. I think I love it. It's awesome.
I mean, we're skirting copyright issues on that.
Just a bit, yeah.
Yeah, just a bit. I don't think they care much. When GarageBand came out, so I'm a musician. That's the career I never pursued. But I'm pretty serious jazz trumpet player. But when GarageBand first came out, it really was a revolution for me anyway. But I think for the industry, suddenly it was super easy to make music, digital music, with very mediocre keyboard skills, which is what I have. And so I started to do these kind of silly pastiche songs where I would, I was like, today I'm going to do a heavy metal song, and I will write lyrics about how unpleasant it is to give birth to babies and make a song for my wife. And then tomorrow I'll do a disco song. And so I have this album from my family of like silly songs that I wrote, which I will not share. But in that process, one of the things I started doing, I was like, well, I'll just do songs for class. And so I did the concurrency control song. And that one was just a karaoke. I stole the background from a popular song. And I thought I would do more. And so the next one was going to be a recovery song set to the tune of Don't Worry, Be Happy. And then that got repurposed as a birthday song for my mother-in-law and never saw the light of day. I am a one-hit wonder in the database song department. But maybe I'll have more time as I'm getting older to do more songs. It's just music's changed so much now. Even the concurrency control song is now an oldie.
Yeah, it's classic though.
Might have to leave it to the next generation to be more relevant.
Cool. Great stuff. Yeah, so before we spoke about that, you mentioned kind of things were easy earlier on in your career, and I kind of want to ask you about setbacks and how you deal with setbacks and rejections, because it's part of doing business in this industry. So yeah, how do you deal with it?
Yeah, well, I'll tell the story of my grad school days, because that was the hardest one, and probably the one many of your academic listeners will resonate with. I wrote my first paper at Berkeley. It was my master's thesis, signed off by Mike Stonebreaker, Randy Katz. I can't remember who else, but famous people at Berkeley. Got to Wisconsin, had sent it to Sigmod. It was accepted. Very exciting. So I was like on the road. Life's good. I'm in the shower one day. Oh no, sorry. Before this, I go on. I gave the talk at Sigmod. Everybody said, "Oh, you're a very smart young man." And then Surjit Chowdhury, who was a couple of years older than me, but he had gotten his PhD already. So let's say 5 years older than me. Came up to me afterwards. He said, "That can't be right." I was like, "Dude, it's right. I have a theorem and a proof. It's right. I'm a grad student. I'm smart." He's like, "No, it can't be right." And we argued, and I was stubborn. 6 months later, I'm in the shower. I'm like, "Oh my God, it's not right. It's wrong." Here's a counterexample. And, I was sure my career was over. I had published a paper. It was wrong. I was going to have to retract it, I guess, right? You can't say something in science that's wrong. And I went into the department at Wisconsin, and I thought that was it, endgame. And I went to my advisor, Jeff Naughton, who's a lovely human being, like just gentle and thoughtful and many things that an advisor could and should be. And he said, this happens all the time. People write papers, they have flaws, and you know what they do? They write another paper, and then they publish that. And it's honest, and it takes part, what was wrong with the previous paper, and it tries to address it. And that's okay. So, what are the cases where your thing is right, and what are the cases where it's wrong? Let's work that through. And so we worked it through. It was a kind of conditionally, it's right under certain circumstances, and when it's wrong, here's what happens. And maybe here's some empirical kind of heuristics you can put around it. Publish that paper. Met Surjit Chowdhury again at some point, fessed up. Every time, I work with him closely. We're co-editors of Foundations and Trends and Databases. And about every 12 months or so, I'm like, Surjit, you always work smarter than me, but you were right about that paper. I have to just fess up annually about that, because it's still, it still bites me a little bit. But the lesson, I think, is the one Jeff taught me, which is that, computer science, fast-moving field, get your results out. If they get published, that's great. That doesn't mean, it's the end of the story. Sometimes things need more work. And if there were flaws in your work, that's okay, but be open about them, address them. It's an opportunity for more conversation in the community. And papers are not like record albums, or maybe they are. But the point is, like your second album isn't your last album. Maybe that's the way to think about it. They're more like a conversation over time. And it's okay for that conversation to have some, actually, I didn't mean, and I'm sorry when I said that. And, it's a dialogue, or maybe it's a community dialogue. And that's hard to learn when you've only written one paper, because you feel like you only got to say one thing and didn't get it quite right. But there's more chances, hopefully, in most people's lives. I've been real fortunate with that, but most people will get to write another paper if they keep at it.
Yeah, that's lovely. Cool. So yeah, while we're talking about ideas and things, this next question is my favorite one. It's about the creative process. I love seeing how people's minds work, and everyone has a different answer to this question. It's how do you approach idea generation, and then once you've generated some ideas, how do you select what to work on for the next 6 months, 2 years, 5 years, 10 years?
Yeah, that's such a good question, and I've changed my approach over time. I also think that it's good to change your approach over time. So I feel like I move back and forth between styles to some degree. So in terms of ideas, sometimes I want to continue and stubbornly on the same idea. Lots of times I want to jump into a new idea. So I do have a little bit of, squirrel chasing tendency on that. Early in my career, particularly, opportunities to collaborate with smart people and work on new things were so exciting that I felt like I had done a lot of small things, and that I had a sense I was doing fine. People would pat me on the head and say I was a clever lad, but I wanted to be remembered for something, and I couldn't articulate to myself what it was that my through theme was, my research vision was. And so in part, this was inspired by Jennifer Whittam, who was another mentor at IBM when I was there, and in some ways a competitor who, again, like Mike Stonebreaker, sometimes the friction there I think was good for me, but very different style. She's a very meticulous person, and I'm less so. She was also at Stanford and I was at Berkeley, so we had to compete. But I could say exactly what Jennifer was working on. She was so good at articulating what she was doing. And I thought, I need to be able to do that. So part of the work that I'm still doing on declarative languages and how they can impact the rest of computer science was me saying, okay, I think this is one of the signature themes of my community. And I think that if I plug away at this thematic advantage of database thinking, I should have an advantage in computing broadly. So I'm going to take, the tools of our trade, take our brand, so to speak, and see what I can do with it. And so that's been deliberate, that I wanted to have a series of projects that had a through theme, while also doing other stuff. I mean, I always have a portfolio going, and that's a luxury of being at Berkeley and having great students who can execute on things when I'm distracted. They can take random ideas I haven't run with them. So that's kind of the portfolio thing of having some through themes that I'm working on at all times, and then have space to explore new things with collaborators who I find inspiring. And that speaks both to idea generation, also methodology, because I think they're hard to separate. Like the craft is the inspiration. I think that's true in music or in art or whatever, as it is in any creative field, that the doing of it leads to the outcomes as much as some spark going off in your head, right? So having big systems projects is one kind of doing. Doing creative collaborations with people who come from somewhere else is a different kind of doing. And in the doing of these things, you come up with ideas.
Yeah.
And they're different. Like, the conversations I have with students where there's 4 of us in a room building an artifact that's been going for a few years, it's very different than the conversations I have the third time I'm meeting someone from another area, and we're trying to understand, we're misunderstanding each other creatively. And, it's just, they're just different.
Yeah. Something you mentioned a second ago there about actually implementing something or doing something can kind of, a lot of ideas can flow from the act of doing. And then this was in the Red Book, which I believe you co-authored, and it was about in the concurrence control section. And it said something like, once you've read these protocols or whatever, you've learnt them, you've not actually learnt them until you've actually gone and implemented them. And once you've implemented, then you've got a proper understanding of them. And I just thought that really hit home with me anyway, because I do that with a lot of things. I'll read something, I think, oh yeah, I've got it. But not until you've actually gone and put it into practice do you realize, maybe I don't really fully understand that. And then once you've done it, you think, oh, it would be cool if I could tweak it in this direction or that direction. So yeah, I kind of, yeah. And those shower thoughts are like the eureka moments. I mean, not many people have those, right? Sometimes the narrative gets retrofitted, like, yeah, I was in a shower or I was under a tree and an apple fell on my head, sort of thing. But yeah, it often doesn't happen like that, right? But yeah, cool.
I think that's something, by the way, that I humbly have learned from music practice, and I think it's certainly true in athletics. Anything that involves the human body, it's 100% true, which is being able to conceive of something and being able to execute on it are completely independent. And the philosophers call this the mind-body problem. How do you translate intent into action? And it's maddening when you're trying to really refine a skill. But I think even for the purely intellectual pursuits of, computer science, writing programs, for that matter, doing math, I think the practice leads to the inspiration.
Yeah.
So very few people are born brilliant mathematicians. Most people, even great mathematicians, it's the doing of the math that makes you better at math. And it's certainly true, I think, for the intricate, tricky bits of computer science, like concurrency control, that implementing it so that you see enough permutations and combinations of what can happen gives you a different intuition. It gets your brain seasoned in a different way. But I think it's true for a lot of things. The apple falls on your head because you were sitting in the orchard, and you got to spend your time in the orchard.
Yeah, I like that. I like on the mind-body thing as well. I mean, you don't believe how many times I've envisioned scoring the winner for England in the World Cup. I mean, like World Cup final, but that ain't happened. So yeah, but yeah,
humility is also good.
Yeah.
I had actually a big epiphany this week because I'm at a certain age where I'm like, so what more skills will I be able to acquire in this life, really? I was washing the dishes, and actually I was cooking. I was making a cake for my wife's birthday, and I was trying to scoop the batter out of the bowl. And I had the bowl in my right hand and the spatula in my left, and I couldn't do it. I had to swap hands. And this trumpet practice thought came into my head, which is, I really need to practice my left hand more. Like any skill that you're not good at is clearly an absence of practice. And I was like, that's ridiculous. Like, do we judge people on how ambidextrous they are? Like, is that part of my personal optimization space that I want to pursue? Like, no, I'm a righty. It's fine.
Yeah.
So, all speaking to this idea that, there are things in life that can be left unoptimized.
Yeah, that's very true. Awesome. So yeah, my next question, and this is, I guess, is kind of the mission statement of the podcast as a whole, and it's about bridging the gap and between academia and industry. And obviously, you've done that with various kind of startups. You've kind of crossed that bridge numerous times. So I kind of want to get your take on what you think the current interaction between academia and industry is like, and how it can maybe be improved going forward, if it needs improving at all.
Yeah. I mean, there's always room for improvement. Right after saying that things are chill and you should just accept it. But I think systems, we can certainly improve our systems. I think it's a wonderful time to be an academic who's interested in entrepreneurship. It's not as wonderful a time as 3 years ago when it was easier to raise funds. And right now, if you're not doing AI, particularly language model oriented, foundation model oriented things, it's hard to get funding. But it is the case that Silicon Valley investors are looking for technical leadership and happy to talk to academics about what it would look like to start a company. It's only the last few years that venture capitalists started coming to research conferences, but they do regularly now, certainly in databases. I mean, they've been going in AI even maybe a little bit longer. And that means that, you'll trip across, if not actually the opportunity to start a company, then someone who has started a company. When I was coming up, it was just Mike Stonebreaker. And, if you didn't like the way Mike did things, you had no other role model really for entrepreneurship and research, at least in databases. And now there's many, many of us have stories to tell. Every entrepreneur I've met overfits their advice to their experience, myself included. So if you only get one person's advice on how to run things, it's not going to work for you, very likely. In fact, it's probably not going to work for their next company either. These so-called lessons are just data points. So you need to amalgamate a bunch of them. Nowadays, you can get that. You can go to Sigmod and talk to 10 people who've had successful exits and talk to them about what their companies look like. And you can talk to 10 more about people who didn't and what they learned from that process. And maybe some of us who've had a little bit of both.
Yeah.
So I think it's great times now for entrepreneurship and learning from other people. Also, just the volume of material on blog posts and stuff on how to start a company is just completely different than it was 10 years ago, even. So there's just lots of good advice out there. It's not that hard to find. Industrial, like big industry research, on the other hand, I think is not in a great state right now. Microsoft continues to fly the flag for Microsoft Research. I know that they are constantly battling about protecting it or making it more relevant versus making it more fundamental. But they have a large and successful research organization, and they're kind of the only one. I mean, there are other research organizations, but they're not dedicated to doing the kind of foundational research that universities and Microsoft Research do. So there's good people at other places, and I certainly don't mean to disparage the efforts at other places, but most of what I see in industry coming into the conferences is, we built a thing, here it is. And those papers aren't bad, but they're very rarely educational. So if somebody says we built a thing and it scales, it's hard to project from that to its relevance to other stuff. And often, they're sort of, if anything, misleading because it's overfit to their environment. It worked at company X, big superscaler X, for task Y, and nobody else has task Y. And so those papers, I think, lead people down the garden path with some frequency in ways that's not so good. And very few of them are thoughtful, honestly, in terms of thinking outside what they build, because these are software engineers, so they describe what they build. That's their experience, and there's nothing wrong with that. It's just anecdotal. Is I think the thing to emphasize when you read those papers is most of them are anecdotal. I was recently teaching the Amazon Aurora, the first paper on Aurora, to my students. And among those papers, I was really pleased at how methodical it was. And it was clearly written by people who had a bigger perspective. And that's an example of a good one, where they're not a research group at all. But there are researchers on that team. And it was written with the mind towards, like, what are the piece parts that make up a system? And why did we choose these ones? As opposed to we built a thing, it scaled. Contrast with the Spanner paper, just to put it right out there, the Google Spanner paper. Here's 4 mechanisms for doing concurrency control. We use all of them. Spanner. The end. What? Well, why so many and how? And no.
Yeah. How did you arrive at that magic number of 4? Yeah. Like, why was the other components that you didn't consider? Why did you discount those? Right. So yeah.
Yeah. So, and that's a technically rich paper, I should say. A lot of these papers, it's like we have idea 1 and we scaled it. At least the Spanner papers, we had 3 or 4 things we mixed together, and it's really complicated and it works. There's no why, but at least it is deep. I mean, it's an important paper in some sense. It's an interesting anecdote.
Yeah, for sure. I mean, it's kind of been quite impactful. It's always the Spanner versus Calvin, right? And that's kind of those two papers came out roughly around the same time, right? I know when I was starting out reading about distributed transactions and stuff, it was you got to pick a side, Spanner versus Calvin, for example. Anyway, I digress.
I never thought of it in those terms. That's interesting. That may be a product of your times. Interesting.
Maybe. Cool. Well, let's talk about current trends and future. So the first one I want to ask is, what's the most exciting advancement that you've observed recently?
Yeah, it's not fair because, LLMs are just so interesting. It's not interesting to say that they're interesting, but it is the biggest thing that's hit computing since the Macintosh, let's say, or the iPhone, maybe. I think of it very much in those terms. Like, it's cool. I want to play with it. Because, it's not like I'm going to understand it any better by reading the papers, because it doesn't matter. And it's not clear I would understand it, or anyone would understand it by reading the papers. But playing with it and thinking about what could I do with this object is super cool. And it's the one research topic that I'm not working on, that if I weren't doing what I'm doing, I probably would work on. The distracting thing about LLMs is that everybody's working on them. And so I don't know how much I would add to humanity or computer science or whatever by doing research in that space. I watch my very close collaborator and colleague, Joey Gonzalez, who's a leader in that area. And he does machine learning systems. That's his full-time thing. He's not like adjacent. Sort of, I'm a database person who is happy to do machine learning. And, his group, they're just getting papers out every few weeks, getting scooped every few weeks, getting more papers out. It's exhausting. And unclear, like if his group didn't exist, would another group pop up and do the same work? Maybe, I don't know. I mean, Joey's really good, so I don't mean to discount him in any way. But if it were me, I think that would be my worry. Is that if I prefer to do something off in my corner where people go, oh, I never thought of that. It just feels more, well, it's more controlled for sure. And it feels a little bit, I might have a better chance of doing something higher impact, where if I didn't do it, maybe it wouldn't have gotten done.
Yeah.
So that's my hesitation of working in that space. But man, you have this magic new question answering box. And we're in the business at some level in databases. One of the things we do is answer questions, answer queries. It's not the only thing we do, but it's one of the big ones that we do. Now there's a new box that answers questions in a completely different way, scoped very differently in terms of what it can do and what it does wrong. How do we bring these question answering schemes together to be accurate and efficient and all that? The thing that really juices me, though, is the idea that the world used to be divided into structured and unstructured data, and that's just not true anymore. So if you wanted to get tabular data out of videos or text or whatever, you can featureize it and get features out, I guess, columns, and then run SQL on it. So now we can query everything with structured queries. Should we? Maybe not. Maybe yes. So now that also raises the question of what are structured queries good for? When is it better to ask natural language queries? And this whole thing is like mutually recursive. It's like, where does the natural language stuff end and the structured stuff begin? Where does the data end and the queries begin? Everything is everything. And it's a really mushy space in that sense, and a very malleable one. So you can view that positively or negatively. But boy, there's going to be a lot of change.
Yeah. I mean, it's kind of, it's almost, it feels from afar. Obviously, I don't really dip my. I've played with ChatGPT and I'm trying to use it more and more actually in my day to day life. Trying to get exposed to it more, but I find it very, as a field, very daunting because of the fact that the output is so fast and it's hard to like get the signal from the noise basically, and it feels very much like a bubble. And it's like, I'm like, okay, come back to me in 5 years when you've got some, like, when you've realized what the actual useful stuff is. But yeah, maybe I should I don't know, persist a little bit more. But for sure, it's going to be interesting to see what implications it has. On the unstructured versus structured thing, real quick, I interviewed a guy on the podcast who had a papers for, I think it was at Cider, and he was like, we were talking about it off air. It's like, yeah, you can kind of give like these LLMs like just numerical data, like just give it random CSV files or whatever, and it can actually reason about those. And I was like, that's just wild. Like, I'm giving it some random numbers, even like, and I just said it was baffling. I was like, wow, that's mad. Really interesting. Yeah, I guess leading off that question a little bit then, what do you think is a promising direction for future research in databases? Maybe in the shadows of LLMs would be a way to scope this question. What's hidden around the corner that's not getting any sunlight and could potentially have a big impact?
Well, I mean, that is the story of my day to day. So I think declarative languages applied to other stuff is an idea whose time has really come. I've been saying that for a long time, so maybe you shouldn't trust me. But particularly as we enter the world where the authoring of code isn't the point, because maybe generating code is something that LLMs can do. What we need to be doing under the covers is going from specification to efficient implementation, which is the magic of query optimization and turning declarative into imperative. And the database community has tricks up its sleeve there. So, I'm doing that in the distributed systems environment. One of the things I like about that environment is there's a lot of data movement. A lot of the cost of building a distributed system is about what data goes where and when. The when part not being as typical in databases. That's where the distributed systems reasoning and the concurrency control reasoning comes in. But that's kind of my jam right now. But I think there's lots of other places. Like you could think about languages for programming GPUs. CUDA's not great. Halide's much better. Halide looks a lot more like a query language. And maybe it came out of the programming languages community really, but database people have a lot to say there. So generally in the connection of programming languages and not, traditionally that was, what's a good language for programming a database or programming over a database? Like object relational mappers and stuff. I think there's stuff to be done where it's like, no, just database ideas are important to compilers, are important to programming language design and the tool chain. And there's people like Max Wilsey here at Berkeley who are programming languages researchers learning from database people. So that I think there's a lot of interest there from the PL community if you go reach out. So I think that's exciting. Dan Susio at Washington's doing a bunch of this on the theory side. We're doing stuff on this on the applied side. There's others, but it's certainly not getting the kind of shine that LLMs get. So I think that's a lot of fun.
Cool. Yeah, I guess awesome. Just one last question from me now, Joe, and that is, what does success look like for you from now over the rest of your career? What are your goals, objectives? Yeah, what does success look like going forward?
Those are the hard questions in life, right? I'd like to see one of my projects succeed in open source. I've never done that actually. So Trifacta, which I think was quite successful, we had lots and lots of users. That was done through non-open source, partly because open source is a vehicle for getting software to programmers. It's not necessarily an important vehicle for getting software to end users who aren't programmers. But I care about programmers, but like half of my work is in the space of improving the experience for programmers. So Hydra would be an example of a thing where, I'd really like to see open source adoption. And I've never played that game really. It is a marketing exercise like any other, really. I mean, what I've seen from my colleagues who've done this successfully is, you go to meetups, it's really just marketing. There's a certain kind of open source marketing that I've never tried. Obviously, the work has to be good, but you don't have salespeople selling it, and you don't write papers about it. You go off and do the thing that makes open source successful. You build communities online. You go to meetups. You do all that kind of stuff. And I think it's gratifying to see people use your code as software engineers, which I haven't had. I've had people, business analysts using my code, marketing people using my code, data engineers using my code. But I'm a programmer. I'd like to see programmers use my code. That'd be cool. So that would be a form of success that I have yet to see that I would enjoy. I do have code in Postgres and things like that. So it's not like I haven't felt it, but it wasn't mine. Postgres is Stonebreakers, right?
Yeah.
I'm proud of it, but so that'd be cool. I'm super proud of my PhD students, and I'd like to see my current crop at least do well. So that would be success. And if I have more students after that, then that's always, that's a very personal one, because you spend 6 years with a person, they're as much family as they are products, right? So I really want, that would be success for me, is to see all those folks have an impact. And I think as you get older, teaching is half of the fun, and in that sense, it would, knowledge isn't useful unless you pass it along.
Yeah. Well, that's a great message to end on, Joe. Thank you so much for speaking with me today. It's been a fascinating chat, and I'm sure the listener will have loved it as well. So, yeah, we'll see you all next time for some more awesome computer science research.